So here we see a nice simple function, a graph of a function which has some peaks and some valleys. We would like to find the value or values of x where the function has a local maximum. So I'm going to look for high points. I'm going to look right here. We have a peak where my function is increasing and then falling, decreasing. So there at x equals 2, I seem to have one option in terms of a solution. Okay. Now there's another point up here. We have another high point. This happens to be the global maximum. This is the highest our function goes, but it is also a relative maximum. So around this point, everything else is lower. So we also have a solution at x equals, let's see, that would be 5 over there. Okay. Now the next question we would like to address is where are these local maxima? What are they? So we found the x coordinates. When we actually ask what the maximum or maxima are, we're asking for the height. So how high does our function actually go? Now looking at that first high point that we found, when x equals 2, it appears that our function is at a height of 1. So I would say 1 right there. I should say y equals 1. And our other local maximum up here, when x was 5, appears to be at a height of 3. So those are our two local maxima, and we'll clear that out. Look at the next question. Do we have any local minima? If so, where are they? Where do they occur? Now we're looking for low points. So I'm seeing 2 points that are lower than everything else in a little neighborhood. I see one obvious choice right here where we go from decreasing to increasing. So there at x equals 3, I see a winner. But there is another low point. So our function also gets pretty low right there at x equals, I guess that would be 1. So this point is also lower than everything else nearby when x equals 1. Alright, so we found the x coordinates of all of our local extrema, the sort of general term for maxes and mins. What about the value of those local minima? Well, they're both at the same height. They both appear to be at 0. So here we've got 3, 0, and here we've got 1, 0. They're both at a height of 0. So I think we would be safe to say there's only really one local minimum. Our function gets as low as y equals 0. Now finally, we would like to talk a bit about the global maximum and minimum. In terms of the global maximum, remember that just means how high does your function go. Ours has a high point here at 3. That's the highest it goes. Now the global minimum, that's the lowest that our function ever goes, and we can see that the lowest it ever reaches is 0. Another way we could state this is that the range is 0 to 3. So our low point at 0 and our high point at 3. Now the final topic in this section is that of zeros. Now zeros are nothing new. This is just a new piece of terminology to describe a particular item of interest for us in analyzing graphs. So the zeros of a function are the x values where that function is 0. Now our functions may have 1 or 2 or 50 or none. Anything is possible. So here we have a nice square-looking graph. We want to figure out where the zeros are. Now remember, zeros are the x values. Alright, so here we've got one place where our graph intersects the y-axis, or the x-axis, where y, or f of x, is 0. And that is occurring at x equals -3. Now there are two such points. There's another one right there where f of x is 0 because we're on the x-axis, y is 0, and that point has an x-coordinate of +3. So that's how you will handle finding the zeros of a function given its graph. We'll talk a bit in class about how to do this using your calculator. So go ahead and get started on those homework assignments. That will be it for section 1 out of this chapter.